Hey, welcome to the Capstone here at, I guess for those my students, SNHU. This is our analytics capstone, and I know that some of you are looking to use our predictive modeling and having a little hesitancy on that. Okay, first thing I want to say is, hey, I'm Dr. Larson. I know we don't get to see each other because we're in a asynchronous course, but hi, this is me. I'm in my home office here, as I'm sure many of you work from home ever since the pandemic. Uh, so I want to talk to you about this final project here. I see a lot of worry and concern over certain tools you have to use, whether or not you can bundle with R. R is difficult in making graphics. All true. There are points in time in an academic situation where I could say, you know what, I'm going to restrict you to only using R. I'm going to restrict you to only using Power BI because I want you to focus on this tool. This ain't the time. We're in the capstone. This is a short semester. It's only 10 weeks total. We're under 9 weeks now because we're into it. Now is not the time to get frustrated and stuck on something you're not really fully understanding. So my suggestion, personally, the way I would take this in, if I was given this assignment, any one of these you get to pick from, I would use more than one tool. I would, if I was going to make some, if I want to make some quick visualizations, want to look, I'd use something like Tableau, Power BI, Excel. If I want to do a quick look through the data, use Excel. There's nothing wrong. There's no shame in that. Use tools you're familiar with, and then we can save R for any kind of predictive model. And I'm going to walk us through a basic predictive model in R, a no frills model. I see a lot of examples out there are very high because one interesting thing about this field is we go from you get people from the computer science world who are software developers, and they develop very intense, very robust software solutions and all this stuff. So even their modeling is, they've used a lot of object-oriented programming, that kind of stuff. Uh, then most of the rest of us come from who knows where else. I came in as a electronics technician. Other people come in from business and all kinds of different areas. So programming is maybe not our strongest point. So I'm going to show you the kind of programming I would do in a situation like this, where because let's face it, we're still kind of in an experimental phase. If I was going to put this in production, yes, I'd get more serious. I'd develop better programming techniques in it. But for just a quick experiment, let's look through this data, see if we can find anything interesting. This is all I'm going to do. So I'm going to walk you through. I'm going to hop into R, and we're going to walk you through what I see and kind of give you an idea of how I would approach it and how I want you guys to approach it, because you do not need to do this whole thing in R. This whole thing does not need to be overly complicated. I accept graphs and charts from Excel, Power BI, however you want to put them together. Keep in mind you've got less than 9 weeks. Make the best of it. Do what you're strong at. Okay, so I'm gonna go over here. Let me pop up into R here. Okay, so this is R. I just want to show. I already loaded the data. I'll show you how I did that in a second. But I picked. This is the attrition project 1 data. And you can look through. One of the first things I always do is just look through the data and say, okay, department, that might mean something. Distance from home, that could mean something. Somebody wants to quit. What their education level might be. These two are probably going to be correlated, because they're one's field, one's education level might have something to do with each other. Employee count. This right here, employee number. I can already tell you this. Not this. You can dump this. This is a field you're never going to use because it's just like a driver's license or any kind of ID type number. It has no value. Other ones, employee satisfaction, gender, hourly rate, job involvement. All these may have some meaning. So what we're going to do is, like I say, I'm going to do a quick and dirty logistic regression, which is a binary classifier. So you guys, this is a true, false, yes or no type classifier. And we'll get into it, and I'll show you how I'll do it. You can go from there. Obviously, you might want to look at putting some other models together, like some boosted models, look for your decision trees, random forest, that kind of stuff. Will perform better than logistic regression, but a logistic regression is always a good place to start. So here I did, right now I brought in our data, just using the data read CSV. And as you see, it's already there. So you can do a summary of the data if you want, and I'll pull up. I'm going to run this. This is the summary, so it gives you some information with the quartiles. You all know that. The biggest thing I want to run up here, if you can see it, if I can adjust this screen a little bit here. Hold on, grab. It's always a little tricky doing this on the fly, but yeah, you can't really see it from where I'm at, but we'll get up there. So we got that one. I'm going to do the next one. I'm going to do is summary data. So summary is here. Let me jump back to that one so you can see. So, oh, there we go. Where So I'm going to click on some string next. So string next, and this gives me, and again, if you look, sorry, not the best at filming here. This gives us all our values and what they are. Some are factors, some are integers. And for those who don't know, and I've already treated this, so I should probably have actually, hold on, let me run something really fast again, just so you can see, because I've already treated the data, so it's kind of messing up the result. So as you can see here, we got a lot of characters, char, integers. So integers are fine. We're good with numbers, but for our categorical data, we definitely want to do something about that. I get my mouse to work again. Okay, so we're going to definitely get that data back there. So what we're going to do is one of the first things I always like to check, even though on this case it comes out as a negative, is I like to check, do we have any NAs in the data? That lets us know if I got to deal with them. And of course, I have none. As per the results, there's none right there, 0 NAs. So we don't have to worry about NAs. But so what I want to do is I went through and I picked each of our variables that was not an integer. And I sat there in business travel and I just converted. I used as factor, data, business travel. And yes, you could use an L apply or an S apply to make this faster, but I just did them all. Just I want to show you that, hey, you don't have to make the complicated program to make it work. So I ran those. Now we should have those, should all be. And then this one here, our attrition. This one is our main factor. So I want to get rid of the yes and just convert it. So I use an if else to convert. If it says yes to 1, otherwise 0. So 0 is no, and then I set it as a factor. So that way, because the attrition is going to be our dependent variable. So that's the one we're looking at. So now when I go back up here and I look at my string and I run this and I come back and look, you'll see everything's a factor now. I mean, we've got factors or integers. So we're good there. So we've gotten that. So we're that far set. So that's the main prep we've dealt with so far. Luckily, this data is not too dirty. I set this seed. If you guys know anything about setting seeds, this is a random seed. And the only thing this does is if you use the same seed I use, which is 555, you usually get the same results. If you use a different seed, you get different results. If you don't use a seed, every time you do it, you'll get the same you get different randomness. So if you're not trying to show this to somebody, don't bother with the seed. It's only so that you guys can try to get the same result. What I'm going to do now is I'm going to do a sampling, okay? So I'm going to sample a set. I want 2 samples. The number of rows come from my data. If there's a replacement, if I got to get rid of something true, you can do that. And probably how I want to cut is my vector, I want 80% and 20%. So I'm going to cut my data into a training set and a test set. The training set will hold 80% of my data and the test set will hold 20%. So if I run this, I've got some new things. And if I went into my test data now and clicked on it, you'll see I've got 1,200 records and my training. Well, actually, you can see over here. Let me try to slide this over so you can see. But you can see, of course not. Does not want to play nice. You can see if I scroll down here that where'd it go? So my test has 258 observations, where my training has 1,100. I mean, 1,012 observations. So it's a little stronger. All right. So let's go ahead back into our data set there. So we've set that and we split them. So now we have 2 data sets. Okay. This help GLM, if you ever run this will kind of give you, it's kind of hard to see. You go to help feature will open up here in the corner. You can see it down here. Of course, it doesn't want to play nice, and it kind of gives you a description. It's down here in the right corner. And of course, I can't get to play, but all down here. It'll kind of help describe the GLM, which is the general linear model, which is the one we're going to use because we're using a linear regression. So the first model we set up here is putting in all the factors. And actually, hold on. I want to make sure, pause for a second because I'm missing some factors here. All right. So I didn't put all the variables in. You should. I'm just doing this as an example. So when you guys do it, make sure you put in all the variables, except you can leave that one out we talked about. You can definitely leave out the employee number, because which one was it here? Monthly. The employee number, that means nothing. So leave that one out, but the rest you want to put in. I didn't put them all in because I'm just running a test here, but this is how we form our test. So we say model, give it a name, GLM, our first variable is our dependent, so attrition's our dependent. That's the one we're concerned about. Then we just start adding up all the other variables we have and put a plus sign next to them. Then finally, at the end with a comma, we name our data, which would be our training set, and then our family, which is a binomial. We're looking for a binomial linear model. So that's, that would be our binomial means true, false, so logistic. We go on there, we run this. Okay, we were boarded for some reason. Hold on, let me pause. What's going I don't know what that was. Weird computer. Just reset it, and it's going fine now. So let's go ahead. Let's look down at the results. So I ran the model, and I'm running the summary of the model now. So you can look up here, and here's all my variables, and you get information like the estimate, the standard error, the z-value. If you know these, that's great. If you don't, take some time later to learn about them. One of the most important thing is your p-value here. The lower the p-value, the more meaningful your data is. So you can see here, these stars will tell you. And what we can do is what's known as stepwise regression. We start looking at ones like this one, this 999. This one's probably garbage. That's job role, human resources. So you'd probably want to get rid of that one and just try running your model over and over again. And you can do that, manually, or you can take this approach, which I'm using, a stepwise regression. So I go through here. I got this library called Mass. And I'm going to put a step A1C, put my model in there, and then as my new model S, and I'll get a summary. And I'm going to run that, and we'll go ahead and see what the results I get are down here. And as you can see, it's going through and it's running the model a bunch of times. If you're watching this live, this is the stepwise. It's doing the stepwise for us. And what it comes out to is this one right here. So it says this is the most efficient model it's able to find, and these are the variables it's finding for. It even gives you the nice thing so you can pick this up and bring this up for your model. But again, what we did is we went through manually. If you watched it, is if you want to do this manually, you would just go through, you'd pick the ones with very high p-values like 0.8 and get rid of these and just see, hey, does that improve my model each time I run this? Okay. And one of the things you're looking for down here is your residual score here in your A1C. You're trying to get these higher than possible, So let's go ahead and let's take the model they told us. And we'll drop it in there, and we'll call this model 2, just for fun. And I've got it in there. I'm going to run this model now. Oops. And okay, so that model is running. And we can do a summary of that model. We already have a summary of that model, so we don't have to run it because this is the summary. It came with the A1C. So now we built the model. So let's go ahead now, and we are going to look at testing the model. So one thing we want to do is we want to test our results. We're trying to predict, is the employee leave or not? Is an attrition? So we sit there and say, we're going to build a results model. So I got a results here. And I'm going to predict based on the new model, which is my good one, which is the one the A1C told me. I'm going to test it up against my test set. Remember, we split. We have our training and test set. And I want to get a response type. And if we run this, what you're going to get is a probability response. So check this out. So if we look down here at the results, what you're getting is probabilities. So this is the probability that number 2 will be. So they're saying it's 0.2, so it's probably 0, 0.05, 0.2, 0.1, 0.46. These are all zeros. 0.7. If it was 0.5 or higher, we're going to say it's yes, because if you remember linear regression or logistical regression, it's an S curve, and you want to try to cross over that threshold of the S curve. Hold on one second. So kind of here, so what you want to think about is, if I get a good example, this is a great one right here. So this is where our data points will be. They'll kind of be along this curve. And if they go above this 0.5 line, we can consider that to be a yes. If we go below, we consider it to be no. This is why it's actually a classifier. It's binomial, but it's a binomial that doesn't just give you like a 1 or 0. Like a random forest will give you like a 1 or 0, that kind of stuff. But this, you get a probability. So we have to weight the probability and say to ourselves, if it is above this line, we're going to call it yes. If it's below this line, we'll call it no. And we set the line at 0.5 normally. And that's what I'm going to set it as. Now, there are examples when you go to tune your thing, you'll find, hey, I only want everything above 0.6 to be true because I don't trust the model as much. So, but whichever way you go about it, that's what the kind of the idea is there. So here we go. We've got that. We've set the prediction. Now I'm going to set the prediction so it means something. So I'm going to say the prediction one is if else, if the result is greater than 0.5, I want it to be 1, otherwise I want it to be 0. So I'm going to get rid of those probability numbers down there, and I'm going to make a 1 or 0 out of it. So if you actually looked now at, if I did a head on my pred 1, and we'll make it maybe 10 so we can see a couple more. And then you'll see down there, they're all zeros on this one. Most of it's 0, I think. But if you go deeper, maybe, here, tell you, it's just for fun. Why not? All right, now we got a couple 1s in there. Not much, but we got a 1 down here, a 1 here. All right, so one thing we can look at, one of my favorite things to look at is called a confusion matrix. So what we're going to do is we're going to build a table, and it's going to have our predicted values, which will come from here. This is what we just gave it, versus our actual values, which is the attrition column from our test table, which is also 1s and 0s. We set this up and we run this. And we get this thing down here, it's a confusion matrix. So here's how this works. You have 0 and 0. So this says I'm predicting 0. This is I'm predicting 0. This is the actual. So I predicted 214. 214 were actually correct. Okay, I predicted 32 to be 0, and 32 of them were actually supposed to be 1. I predicted 1 to be 7. I predicted 7 to be 1, and it was actually 0 if you read it this way. And I predicted 5, and I predicted 5 correct. 1 and 1 were 5. So actually my 1's predictions are not very great. Okay, it's, but it is heavily skewed, and there are things to look at for skewed data, things like SMOT and AdaSense, like you can improve. I'm just trying to get your feet off the ground here. So finally, we can just do a quick measurement, and A1C mean. So we sit there, we say actually going to be the mean of predicted, so my predicted, is equal to test attrition, and this will give me a result, okay? So there you go. That's 84, 85% accurate. Now I say accurate with quotes around it, because when you're dealing with imbalanced data, sometimes, the balance isn't very well. Think about like an example, like in my dissertation, I did a credit card fraud, where 1 in 30,000 rows were fraudulent. So if I went through and just said everything was accurate, everything was not fraud, my accuracy score would be 99.9999. So that's why you want to look at things like confusion matrix and some other metrics to look at. They're very important. The metrics, I always say, are more important than building a model. Anybody can build a model. The computers make it so easy for us now. But so I'm going to post this video up, and I'm also going to post this code up as just a primer. This is not, I'm not telling you how to do it. I'm not telling this, but for anybody who's feeling stuck and a little hesitant, this is a primer to get you started, at least get a model built. If you would use a different data set, obviously you have to change the names of the variables and stuff like that. And, if you enjoy making visualizations in R, some people are really good at it, go for it. Exploration R, go for it. Go for it. If you got it. But if not, if that's your hesitation, if that's your breaking point, we're on the Capstone. Excel. Use Excel. Use Power BI. Use Tableau. Whatever you want. You can get Tableau for free because you're a student. Use them. They're most likely faster. It's something I would use in the real world. Honestly, when it comes to visualizations, I'm just faster with other tools than I am playing around with R and Python. Anyway, I hope this helps. I know there's not a whole lot I can do with this asynchronous solution, but maybe I can make some of these videos along the way to help out. And that's good to see, at least me, if somebody, there is somebody on the other side who's grading it. So good luck, and any questions, feel free to reach out.